Hello everyone, Assalamu alaikum. Uh, Today I have brought a new tutorial based on some challenging questions from different past papers um, on the topic of equations of motion. In this tutorial, we are going to learn how to apply equations of motion and in different practical situations. The tutorial is going to help students of different levels, particularly the AS level physics examination, those who are going to appear for their AS level physics examination. Obviously, this tutorial is going to be helpful for them in learning how to apply the equations of motion at different circumstances. Students who are going to appear for ADEXL, CBSC, MDCAT, ETA, NUST, GIK, FSC Part 1, Class 9th Physics, of course. Now, obviously, at different levels of examinations, you can be tested in physics, particularly students who are going to appear in their higher secondary or going to appear for any of the entrance test for universities. So you will be tested with some challenging questions. So this video is going to help, and this video contain four questions, and we're going to explain and we're going to solve each of them one by one. My name is Abdul Rauf, and I'm the faculty member of Cambridge Assessment International Examinations with certification and experience. You can send your queries on my WhatsApp number as it is shown, and of course I will be trying my best to help you as much as possible. So let's going to go and start the tutorial. So before continuing, I would recommend you to pause the video, and you should have some kind of a notebook where you're going to note down, and of course a calculator for calculations. And I would want you to solve along with me to make this tutorial as much as possible, to be more effective. A person traveling on a motorway a total distance of 200 kilometers. He travels the first 90 kilometers at an average speed of 80 kilometers per hour. Which average speed must be obtained for the rest of the journey if the person is to reach the destination in a total time of 2 hours and 0 minutes? This question is from October-November paper 12 2010. Question number is 6. So the first thing to solve such sort of problems is to understand the situation, what actually kind of situation is given to us. So as you can read it over here, they say that the total journey for the person to be traveled is about 200 kilometers. Then out of 200 kilometers, the person is traveling 90 kilometer distance at an average speed of 80 kilometers per hour. So that means we don't know how much time he took for the first 90 kilometer distance. Okay, now then they say that okay, for the rest of the journey, how much time the person, how much should be the average speed of the person. Now if you look here, the total time for the journey is given, and if we find time for the first 90 kilometers and subtract that time from the total time, then we will have the remaining distance and the remaining time of, you would say that the time for the remaining journey. So then we can recalculate the average speed for the remaining 110 kilometers. So as we can see there, the total distance to be traveled is 200 kilometers. Okay, and for the first 90 kilometer distance, the average speed is given to us as 80 kilometers per hour. So let's calculate the time for the first 90 kilometers. So now what equation we are going to use here? Are we going to go for any of the equations of motion? Yes, you're right. we are going to use the average speed formula. Now, what is average speed formula? Average speed formula is total distance covered by total time. We can write V as V equal to S by T. S represent the total distance over here. You can write D by T as well. In many books you would see they can use D as well, so there's no harm either using S or D for distance. So we are going to find time, so let's make T as subject, and now let's plug in the values for distance and average speed. So we get 1.125 hours. Now this is the time for the first 90 kilometer distance. Okay. All right. So as we know that the total distance of the journey was 200 kilometers, and out of 200 kilometers 90 kilometer distance is already covered, so the remaining distance would be 110 kilometers. And let's see how much time will be left out of 2 hours for the remaining journey. So the total time was 2 hours, so we can subtract 2 hours, in fact 1.125 from 2 hours, so we will get 0.875 hours for the remaining 110 kilometer distance. So we have the time for remaining journey, we have the distance for remaining journey, and we are asked to calculate the average speed for the remaining journey. So let's reuse the average speed formula as average speed equals total distance by total time, and just plug in the values as total distance now is 110 kilometers and the time for 110 kilometers is 0.875 hours. So dividing the two, we get 125.7 kilometers per hour, which can be rounded to 126 kilometers per hour. So according to the problem, this is the time which is required to cover the remaining journey, which is of 110 kilometers in with 126 kilometers per hour, to reach the destination. So let's see what options are we given. All right, we are given 110, 120, 122, and of course 126 kilometers per hour. So the correct option over here would be 126 kilometers per hour. So what we noticed over here, first we found the data, we extracted the things which were required from us and the things which were given to us, we understood the situation, and then we chose the correct equation, which was the average speed formula over here, and then you just plugged in the values and did the correct calculations, and of course you got your answer. This is the next problem. An aeroplane travel at an average speed of 600 kilometers per hour on an outward flight and at 400 kilometers per hour on the return flight over the same distance. What is the average speed of the whole flight? We are given options, and this question is selected from paper 12, October, November 13. Now first let's understand what is the situation and what kind of situation we are going to be exploring over here. Now as we see, they say that the airplane is going with an average speed of 600 kilometers per hour on an outward flight. So let's assume that an airplane starts from one airport at a certain city, and when it goes, the average speed for the airplane was 600 kilometers per hour. Okay, now when the airplane was returning, the average speed for it was 400 kilometers per hour. Okay, but now there is something very important to be noticed, guys. You see, they say over the same distance. What does that mean? That means that the distance traveled by the airplane while going from the first point, as you consider one city to another city, and coming back from that city to the initial position or the initial city, you would say, that remain the same. So distance while going outward or going inward remain the same, and the average speeds for outward and inward flights are given to us. And now they want us to know how much would be the average speed for the whole flight. Means the airplane started from one city, went to the other city, and then came back to the first city. So we are given the average speeds for the outward and the inward flights, but they want us to find now the average speed for the whole journey. So what can we do? We have average speeds, okay, and we also have the total distance. So say let the distance covered by the airplane when it was going outward was s, and let the airplane when it was coming back has covered the same distance. So let also, so we can represent the distance for ourselves. What we do not have is the time. We don't know in how much time the airplane went from one city to the other on the outward flight, and we also don't know how much of the time it took when it was returning from that position to the first position. So let's going to find now the times for the outward and for the inward flights, considering the fact that the distance while going outward or coming back remain the same. So the total distance can be d plus d, you can say s plus s, whatever you can choose. Okay, so you let's choose over here as d plus d. So let d was the distance when the airplane went, and then another d is the distance when it came back. Okay, so since it remains same, so we are not going to write 1 2, so we are just going to add d plus d. So the total distance covered by the airplane is now 2d. Since we are asked to find the average speed for the whole flight, so using the average speed formula as total distance by total time, how much is the total distance? That is 2d. How much is total time? Let's represent that with capital T. Now we don't know how much time it took while it was going outward and then coming into inward, and we also don't know what was the time for the outward flight and what was the time for the inward flight. But what we can do is we can find the time for the outward flight, we can find the time for the inward flight, and then we can add the both times and get to know the total time for the whole flight. Now, so to calculate the total time t for whole flight, first calculate the time for the outward flight as t1, and then time for the return flight as t2. So let's calculate the time for the outward flight using the average speed formula as total distance by total time. Since we have average speed, we have the distance, we have represented the distance with d, so we will make the t1 as the subject. And now let's find the average speed, in fact the time for the return flight, using the same equation again. So average speed is equal to total distance by total time, which is 400 kilometers per hour equals d by t2, and let's make the time means t2 as subject again. Why we are making times as subject? Because we need to know the total time. So we are going to add this t1 and t2, and then we will be able to know the total time. So let's add the two times for the outward and the inward flights to calculate the time for the whole flight. So t1 plus t2, t1 was d by 600 and T2 was D by 400. So we're going to add these two numbers, D by 600 plus D by 400. So now there is a situation where we have these numbers in fraction form. So whenever there are numbers in the fraction form and they are to be added or subtracted, we have to take LCM. So let's take the LCM. So what would be the LCM for 600 and 400? Let's make it easy for ourselves rather than finding out and going for that long process. What we do, here's a shortcut for you now. What you can do, you can write the denominators 600 and 400 multiplied to each other as, and now write the numbers above D by 600 and multiply the LCM with this. And now since you have the plus sign, okay, so you're going to write the plus sign and now rewrite the D by 400 and multiply this number also with the LCM. Okay, now what next we can do, we can cancel out what can be cancelled. So you can see 600 and 600 can be cancelled. Okay, and then on the other side, if you see 400 and 400 can be cancelled. That's fine. So what is left now? 400 into D plus 600 into D. So if we multiply the 600 multiply 400, we get 240,000 and write 400D plus 600D which were remaining. So when you add 400 plus 600, you will write 1000. Since D is common, so you can just take the D common and write one time. So 1000D divided by 24,000. So now you can cancel out the zeros. The three zeros can be cancelled out. And you're left with 1 by 240 into D, or you can write D by 240. Now, this is the total time for the whole flight. The capital T represents the time for the whole flight, which is equal to D by 240, average speed formula. And since we know now the total distance is 2D divided by, and the total time is T, so you can rewrite the equation as 2D divided by T. So let's plug in the value for T, which is D by 240. So it become 2D by D by 240. Now this 240 will go up according to the mathematics rule. So this will become now 2D multiply 240 divided by D. I hope you know this. When you see this number, this is considered in division form, the 240 I'm talking about. Now you're going to multiply this with the 2D. So what we can do now is we can cancel out the D's and we are left with 2 into 240, which is equal to 480 kilometers per hour, which is the average speed. So let's see what we are given in the options, and the correct option is, yes, you're right, that is C. So what we did in this particular question, we first found the time for the outward flight and we found the time for the inward flight, and then we added the two times and we plugged in the values in the average speed formula. But the important point was that the distance for the outward flight and the inward flight remained the same, and we had to notice that point. I hope this was clear. Let's move on to the next question. Now it says, in a cathode ray tube, an electron is accelerated uniformly in a straight line from a speed of 400 into 10 power 3 meters per second to 2 into 10 power 7 meters per second over a distance of 10 millimeters. What is the acceleration of electron? You can see the options are given to us, and the reference for this question is paper 13, May June 2014. So you can see they're talking about the CRO, which is normally studied at different levels, at initial levels particularly, even in O levels or in metric. So they say that an electron is accelerated uniformly. They have to use the word uniform because the equations of motion can then be used if the acceleration is uniform. Now they've given us two speeds, which is from 4 into 10 power 3 to 2 into 10 power 7. Now they've used the word speed, but we have to consider these two values as the initial velocity of electron and the final velocity of electron. Over a distance of 10 millimeters, mm stands for millimeters, so we need to convert the milli obviously later on into the SI units. So they want us to find the acceleration of electrons. So we have initial velocity as 4 into 10 to the power 3 meters per second. You can write U, you can write VI. For FSC and metric students, they use normally VI, and for Cambridge and other international systems, they use U. Final velocity V, they use as VF. So it won't harm, so you can just use VI, VF, or U and V. So V is 2 into 10 to the power 7 meters per second. The distance to be traveled by electron is 10 millimeters. Okay, so how much is 1 millimeter, by the way? Yes, it was 10 to the power minus 3. You're right. So what we are supposed to find is acceleration. So you have three equations of motion. V as u plus at. If I'm using the first equation, it contains time also, but in this whole situation, you're neither asked about the time nor it is given to you. So we should not use the first equation and even the second equation, because in second equation again there is time. Second equation, as you remember, S equals to ut plus half at squared. So we're going to go with third equation of motion as 2as equals v square minus u square, or vf square minus vi square. Since we are asked to calculate acceleration, so we should make a as subject. So you can plug in the values and later on make the a as subject, or you want to do it right now, so that is your choice. So a equals to v square minus u square divided by 2s. You can see I have changed the sides of 2 and s and left a alone on the left side of the equation. So you can do the cross multiplication or divide both sides by 2s. So you will have v square minus u square by 2s as shown. Now so let's plug in the values, knowing that the value for v is 2 into 10 to the power 7, and since it is squared, so we have to put square as well, minus u, which is 4 into 10 to the power 3, okay, divided by 2 into s. So let's write 2 into 10 millimeters. So for millimeters we should convert as 10 into 10 to the power minus 3, knowing that 1 millimeter is equal to 10 power minus 3. Okay, hope this is clear till now. What we have done, we have just plugged in the values of each quantity here as v, u, and of course s, since we are going to find out a. So let's do the simplification. So taking square of 2 will give us 4, and taking square of 10 power 7 will give us 14. 10 power 14, remember 7 power 2 will make it 14. Okay, so this will be now 4 into 10 to the power 14 minus, again 4 square is 16, and 10 power 3, this will become 10 power 6. 3 into 2 will become 10 power 6, and 2 into 10 will become 20 into 10 to the power minus 3 as it is. Okay, now there is something very important to be considered over here. How we can go ahead? Mostly, I see students, they just plug in all these values in the calculator and expect that they get the correct answer. But that depends if you know exactly how to give the commands for giving such sort of equation in your calculator. If you don't know exactly the commands, then most of the times you'll get the wrong answer. So what is important over here to consider that we cannot directly subtract the values as 4 into 10 power 14 minus 16 into 10 power 6. Why? Because both the values have the multiples of 10 of different powers. You can see one is 10 power 14, the other has 10 power 6. If it was multiplied, then there was no issue. But since this is to be subtracted or added, even if it was addition, you have to do what we are going to do right now. So what I am going to do now, I have to make the 10 power 14 and 10 power 6 as same powers. So either you are going to convert the 10 power 14 into 10 power 6, or you are going to convert the 10 power 6 into 10 power 14. That is your choice, but it should be same. Once the powers are same, then you can take the common. So how we are going to make these powers as same? So see now, I'm writing 4 into 10 power 14 as it is, and I'm going to convert the 10 power 6 to 10 power 14. Okay, so we're going to move the decimal, as right now it is considered as 16.0, although it is not written there, but you can consider it as 60, because if you're writing 16 or 16.0, that is mathematically the same value. So that means we're going to move the decimal point onto one side to make the 10 power 6 as 14. How can 10 power 6 become 10 power 14? By adding 8 to 6, it will become 14. That would mean we need to add 8 to 6 to make it 14. So to adding 8, that would mean that you need to move the decimal to the left of 16 by how many digits? By total of 8 digits. But since there are already 2 digits present, now let's see, we are going to add 8 with 6 to make it 14. So see what I'm going to do with the decimal here. Now you can count how many digits the decimal has moved. It is 1, 2, 3, 4, 5, 6, 7, 8. Now 1 and 6 are considered as 2 digits. They were already there. So I have moved the decimal by more 6 digits. So there were no digits. So you have to plug in the zeros from yourself according to the mathematics rule. So now you can count the total number of digits by which the decimal has moved are actually 8, and 2 were already present, so you just put on 6 zeros now. So hope this point is clear. So now you add 6 plus 8, this will become 14. So rewrite the rest as it is, 20 into 10 to the power minus 3. Now what we can do, we can get the 10 power 14 as common, and then you can subtract 4 minus 0.000, comma 00016, and now see, I have taken 10 power 14 as common. Okay, all right, so let's subtract this number from 4 is shown, so this will become 3.999984 into 10 to the power 14, which we took as common. And the next thing we are going to do here, you're going to move the 10 power minus 3, which is multiplied with 20, up there, and this will become 10 power plus 3. So when you move the number with the power up or down, the signs of powers do change. So the sign of the power right now was minus 3, so it become 10 power plus 3 divided by 20. Now what you can do, you can divide the two numbers, only the numbers, so you get 0.19999, and you can write the 10 power 14 plus 3. Knowing that there was a rule in mathematics, when the bases are same and they are to be multiplied, then you can simply add the powers. So we have just added the powers, so it will become 10 power 17 then. So we get this number as 0.1999 into 10 to the power 17. So if we round off this number, so this will become 0.2 into 10 power 17. Okay, it will affect the power again. Now you have moved the decimal one digit to the right. So what will happen with the 10 power 17? You will subtract 1 from 17. Knowing that when you're moving the decimal to the right, you need to subtract. When you're moving the decimal to the left, you need to add. And how many digits are you going to move the decimal? That number is going to be subtracted. Okay, so we have this now as a equal to 2.0 into 10 to the power 16 meters per second squared, since this is acceleration. So let's see the options. The options are, you can see there, all the numbers are written with 2. Okay, and if you consider the powers, yes, the option D is the correct option, which is given as 2 into 10 to the power 16 meter per second squared. So if you see in this particular question, the reason why I solved this question for you was that it contained some mathematics. Like there was not much of physics. You just need to choose the correct equation, of course, and extract the data correctly. But then all was about the mathematics, what you're supposed to do with the 10 powers. First you need to make them same, and then you can extract as common, and then of course you were trying to move the decimal. So most of the time when students start solving such sort of questions, they do make mistakes, not in the equations, but they do make mistakes in such sort of mathematics. So hope this will help you now to solve such sort of questions ahead, and understand the mathematical points as well. All right, we're going to go to the last question of this tutorial. As you see, let me read it for you. An insect jump with an initial velocity of 1 meter per second, reaching a maximum height of 3.5 into 10 power minus 2 meters. Okay, I have forgotten to write a word meters over here, but it is meter. Okay, assume the deceleration is uniform. What is the magnitude of deceleration? Okay, now this question is chosen from 2015 May June 11, question number 8, with the options given. So let's understand what the situation is given to us. They say that there was an insect which jumps with initial velocity of 1.0 meters per second. So that means that initially, as it starts to jump, its velocity is 1.0 meters per second. This is the initial velocity of the insect. Okay, now as the insect go up, it will go up to maximum height. The word maximum height is mentioned in the question. Okay, so it makes some very important point. How much is the maximum height? Okay, that is as 3.5 into 10 to the power minus 2 meters. All right, now why it is important to mention the word maximum height, or what hint is given by the examiner to us when we are solving this sort of question? Now the hint is, whenever an object is thrown vertically upward and it reaches to its maximum height, then it is obvious that the object would have its final velocity as 0. It will always have its final velocity as 0 whenever the object is thrown vertically upward. Why it would be 0? Because of the effect of the gravity. So obviously now you can understand that the object started with 1 meter per second and going up to 0 meter per second, it is decelerating, which was another hint in the question which was given to us, that calculate the deceleration. So you can understand that, okay, if it is decelerating, then its velocity, the final velocity, should be approaching to 0. But since they have used the word maximum height, so we have to understand that, okay, at maximum height the final velocity would be 0. So this is the point which is repeated in different questions, you need to understand. Now the same is written over here. Why the final velocity of the insect would be 0? Because of, you know, the effect of gravity, as it's the insect or any other object which is thrown vertically upward would want to go up, but the gravity will continuously, you know, pulling it downward. So hence it will be you know, stopping at one point, and that point would be as its maximum height. So at maximum height the velocity would be 0. So we have now initial velocity, the final velocity, and we have the maximum height as well. We need to find acceleration. So again, if you look here, I'm going to go with the third equation of motion. The reason is neither we are given you know, any data regarding the time, nor we are asked to find out the time. So it's very simple to go for the third equation of motion. So the third equation of motion as 2as v squared minus u squared. Now let's plug in the values, but before plugging in the values, let's make a as subject as we did before. So a equals to v squared minus u squared by 2s. Now considering that v is 0 and u as 1, so let's plug in the values. 0 squared minus 1 squared, 2 into s, which is maximum height, as h, so that is 3.5 into 10 to the power minus 2. So 0 squared is 0, of course, minus, you will write minus there, and 1 square is 1, so you'll get 1 divided by 2 into 3.5 will make it 7, so that this will be 1 divided by 7 into 10 power minus 2. Now if you move the 10 power minus 2 upward, that will become 10 power plus 2. Okay, so we have minus 1 by 7 into 10 power plus 2, of course. So just simplify. Now when you divide 1 by 7, this will be 0.142. So write the negative sign as it is and divide 1 by 7, so get 0.142, multiply by 10 power 2. Okay, so what we're going to do with the decimal again, if I want to you know, eliminate this 10 power 2, I need to move the decimal to the right or to the left. I should move it to the right, because by moving it to the right, I have to put then a negative sign in the power. So how many digits should I move the decimal? Since I want to eliminate 10 power 2, so I should move the decimal by 2 digits to the right, and then I can write, you know, see, 0.142, the decimal goes from 0.1 to 14. Okay, so it has moved distance of 2 digits to the right. So now you can write 10 power 2 minus 2. Why minus 2? Because you moved the decimal to the right. So when you are moving the decimal to the right, you need to put the negative sign. When you are moving the decimal to the left, you need to put the positive sign. So what will happen when you write 2 minus 2, it will be 0, and 10 power 0 is 1. Anything's power 0, anything power 0 is 1, actually, another rule from mathematics. Okay, so we have now acceleration as 14.2 meter per second squared. All right, so this is the deceleration. Of course you can write a, but the negative sign shows that this is the deceleration, which is 14.2 meter per second squared. Let's see the options now. Yes, we are given the option C as the correct option, which is 14.2, but now they have given us just 14 meter per second squared. So in this tutorial I had chosen these 4 questions, and I hope you know, it will help you. So I am going to solve more questions and going to upload more videos. You need to stay tuned, and in case you find any of the particular question difficult or you want my help, you can feel free to contact me. You can send in your queries, and of course you can give me feedback in the comments as well. So stay tuned to the channel. I will be uploading more and more particular kind of tutorial which will be helpful for you later on. And so that's it for today. See you then. Allah Hafiz.